Okay, so let E to B be a covering space, and choose an element in capital E, and consider the element in B, which is the value of pi on that element in E. Call it E naught, little e naught, and little b naught. Consider these topological spaces. There's three topological spaces here. Each of them we understand is equipped with a subspace of the compact open topology on the set of continuous maps between two topological spaces. So this one is, so it's a capital omega subscript E naught of big E, termed the base loop space of E. It consists of those paths in E, so continuous maps from the closed interval into E. Not all continuous maps, only those whose values on the endpoints, on 0 and 1, agree with the selected element of capital E. Do exactly likewise for capital B. And there's this variant of this one. This is not a very, pay less attention to this one. It'll be gone soon. Call it paths sub E naught, comma, pi inverse of B naught. It consists of those paths in capital E, so continuous maps from the closed interval to capital E. Not all, but those whose value on 0 is the selected base points of capital E, little e naught, and whose value on 1, well, it's not an arbitrary element in capital E, but it lies in the fiber of little b. Because the fiber is discrete, then this topological space has many connected components, at least one for every element of the fiber of B naught. In particular, there's this topological space, which is a union of path components of this one. So there's an inclusion, obviously, because the condition that the value at 1 is E naught is weaker than the condition that the value of 1 is in the fiber of B naught. So there's an inclusion of topological spaces like this. There's obviously a map of topological spaces like this. Indeed, given a path in E, that determines a path in the base. Just post-compose by pi, the covering map. So this is given by gamma tilde, goes to pi precomposed with gamma tilde. Also, that same expression, in fact, determines a map this way. Gamma tilde, pi of gamma tilde. Making this triangle obviously commute. So in other words, if you start here, regard it as in here, then apply this map, it'll agree with just applying this map. Clearly, the expressions are identical. But what we just finished establishing is, in fact, every element in here determines, by unique path lifting, an element of here. And furthermore, once we have the unique homotopy lifting property, given two homotopic loops in B, the resulting paths will be homotopic. So to phrase what that map going the other way is, let's apply, there's this triangle of continuous maps among topological spaces, apply path components to this diagram to obtain a triangle of sets. So apply pi naught to everything. And the unique path lifting property gives that each loop in here lifts to a path in E starting at E naught and ending somewhere in the pre-image of B naught. And that assignment does not depend on the path components in that base loop space. So we get that this map by the unique path lifting property has an inverse. These implement a bijection. And the conclusion from that is that this inclusion, or this inclusion of connected components, path components, through this triangle implies that this map is in fact injective on path components. So to state that corollary, which is the main corollary of all this, let's introduce a definition. In general, given a point in a topological space, you can define this set, which is called the fundamental group of x at little x naught. It's simply the set called pi1 of x semicolon x naught. It's defined to be the set of path components of this base loop space of x. And what we just witnessed up here is what we argued here was a proof of this corollary that, again, for E to B, for the same preamble, we get that this induced map on fundamental groups is injective. So that's remarkable because it's the first corner of this classification of covering spaces in terms of B. Namely, this suggests that there's maybe like a one-to-one correspondence between covering spaces of B and subsets of the fundamental group of B. And there's a sense in which that is true. And that will be the topic of the first parts of next semester.